Okay, writing linear equations. So, when you're writing a linear equation, you need to have an equal sign and pay attention to the variables. Okay, so let's read this. Lucy is tracking, so she's keeping track of the progress of her plant's growth. Today, the plant is 5 centimeters high. The plant grows 1.5 centimeters per day. So we have that per day again. So write a linear model that represents the height of the plant after D days. So we have two variables going on. We have the height, and then we have D, days. So write a linear model that represents the height. So what does the height equal? So the starting point of the plant is 5 centimeters. And it grows, so it's going to go up 1.5 centimeters per day. So that per day means to multiply it. So this is my equation. Now B reads, what will the height of the plant be after 20 days? So we want to know the height after 20 days. So that means we have to plug in D equals 20. So it's going to be the height equals 5 plus 1.5 times 20. So the height equals, and you can calculate this, centimeters. So 1.5 times 20 is 30, so it's 35 centimeters is the answer. Make sure you answer in units. Okay, number 2. Mr. Thomas is on a diet. He currently weighs 260 pounds. He loses 4 pounds per month. So loses means minus. Write a linear model that represents Mr. Thompson's weight after M months. So our two variables are going to be weight and months. So what is his weight equal to? Well, it starts at 260 pounds. And he's losing, so it's going down 4 pounds per month, so it's minus 4m. Now part B, after how many months will Mr. Thompson's reach his goal weight of 220 pounds? So his weight is 220 pounds, and we want to find the months. So we're going to set W equals 220. So 220 equals 260 minus 4m. So M equals 10 months. You want to make sure you have a unit. Okay, number 3. Paul opens a savings account with $350. He saves $150 per month. Assume that he does not withdraw any money, so take any money out, or make any additional deposits, put money in. Write a linear model that represents the total amount of money Paul deposits into his account after M months. So the total amount of money will let be T, and then we have M. So T equals, what's his starting amount? So he starts out with $350, and he's saving, so he's adding $1.50 a month. Now the next question is, after how many months will Paul have $2,000? So we want to solve for months, and we know his total. So we're going to let 2,000 equal 350 plus 150m, and then we solve for m. So answer in months. I don't have my calculator, but answer in months. And the 4, the population. So the number of people in Bay Village is 35,000 today. Every year the population of Bay Village increases, so that's going to be add 2,000 people. So it's, or 750 people. Write a linear model that represents the population of Bay Village X years from today. So that represents the population. So P is going to be my variable and X is going to be my variable for time. So the population is equal to the number of people they have now, which is 35,000, plus, because it's increasing, 750 people per year, X. Part B, in approximately how many years will the population of Bay Village be 50,000 people? So the population is 50, so you're going to plug in 50,000 in for P equals 35,000 plus 750X. And then you solve for X, so it's X equals blank years. Okay, number 5. Connor has 25,000 in his bank account. Each month he spends $1,500. He does not add money to the account. Write a linear model that shows how much money, so we'll let that be M, will be in the account after X months. So money equals the starting amount, which is what he has now, 25,000, and he spends $1,500 a month. So it's going to be minus 1,500 X months X. How much money will Connor have in his account after 8 months? So we're going to plug 8 in for X because X is months. So it's going to be 25,000 minus 1,500 times 8 is going to be your answer. And you're going to answer in money. And then number 6. A cell phone plan costs $30 per month for additional plan plus 15 cents per text messages. Write a linear model that represents the monthly cost of the cell phone. So represents the monthly cost, what that we see, if the user sends T text. So T text. So the cost is equal to $30. Now this is just for a month. So we don't have to do 30M. It's just going to be $30 for a month. Plus 0.15 per text message T. So second part, if you send 200 text messages, so plug 200 in, how much money would you have to pay? So we're going to calculate that and make sure that you put money in. Okay, number 7. 7 and 8 are a little bit different. So Amory has X books that weigh 2 pounds each and Y books that weigh 3 pounds each. The total weight of his books is 60 pounds. Write a linear model that relates the number of 2-pound books. So the number of 2-pound books is X, and the number of 3-pound books is Y. So the total amount is 60 pounds. So it's 2 pounds each for X plus 3 pounds each for Y. So this is kind of a different looking equation. It doesn't look like a rate and a starting amount. So B is, if Amory has 10 3-pound books, so we're going to let Y be 10. How many 2-pound books does he have? So solve for X. So I'm going to do 60 equals 2X plus 3 times 10, because Y is 10, and solve for X. This is kind of similar, the next one, too. Max sells lemonade for $2 per cup and candy for $1 per bar. So write a linear model that relates the number of cups of lemonade he sold to the number of bars he sold. So number of cups C, number of bars B. So he made $425 and sold $2 per cup of lemonade plus $1.50 per bar. Next part, if Max sold 90 bars of candy, so if B equals 90, solve for C. So 425 equals 2C plus 150 times 90. Solve for C. And you can do that. Just make sure that you answer in cups.